Hey everyone, and welcome. You know, sometimes in math, there are these little mysteries, and today we're going to be math detectives. We're going to solve a really cool case all about fractions and decimals. So, let's get started.
Okay, so take a look at this. We've got two super simple fractions, right? On one side, you've got 1/2. That turns into 0.5. Nice, clean, simple. It just ends. But then, look at 1/3. It becomes 0.333, and it just keeps going and going and going forever.
So, what's the deal here? Why are they so different? One stops dead in its tracks, and the other one just runs on forever. Kind of weird, isn't it? That's our big mystery for today. We're going to put on our detective hats and figure out exactly what's going on. Let's find some clues.
All right, let's start our investigation. First things first, every good detective needs to know the lingo. So let's give these two types of decimals their proper names.
So, the first type is called a finite decimal. Finite is just a fancy word that means it has an end. It stops, you know, like 0.75. You got the 7, you got the 5, and that's it. It's done. Super straightforward.
And then, of course, we have the other kind, the infinite decimal. Infinite means, well, it goes on forever. It never, ever stops. You know, like 0.666. Those sixes just keep going and going. These are the ones that feel a little bit more wild, right?
Okay, now for the super fun part. What if I told you that every single fraction has a secret code? A hidden clue that tells you right away if its decimal is going to stop or go on forever. No division needed. Sounds cool, right? Let's crack this code. So where is this secret hidden? You ready for this? It's all about the bottom number of the fraction. Yep, the denominator. That one number tells you everything you need to know. It's the key to the whole mystery.
All right, so here's our detective method. It's got 3 simple steps. Let's try it out with the fraction 3/8. Okay, step 1. Make sure the fraction is as simple as it can be. 3/8? Yeah, that's already simplified. Check. Step 2. We need to look at that bottom number, the 8, and break it down into its smallest building blocks. We call these prime factors. So what numbers multiply to make 8? Well, it's 2 times 2 times 2. Think of them like Lego blocks. Now for step 3, the big one. We just look at those blocks. What do we see? Are they only 2s or 5s?
Yes, look at that. It's only 2s. That's it. And here's the secret rule. This is the whole thing. If those building blocks are only 2s or 5s or a mix of them, then you've got a finite decimal. It's going to stop. Since all we have are 2s, we know for sure that 3/8 is a finite decimal. Awesome, right? Case closed.
Okay, now it's your turn. Let's try another one. 7/15. What do you think is going to happen with this one? Is it going to be finite or infinite? Use our detective method. Look at that bottom number, 15. What are its building blocks? Go on, give it a try.
All right, let's see how you did. Step 1. Is it simplified? Yep, 7/15 is as simple as it gets. Good. Step 2. Let's break down that bottom number, 15. What multiplies to make 15? That's easy, it's 3 times 5. So step 3. Let's look at our blocks. Do we see only 2s or 5s? Uh-oh, no way. We've got a 5. That's fine. But look, there's a 3 in there, and 3 is not a 2 or a 5. That 3 is our troublemaker. It breaks the rule. As soon as you see a prime factor that isn't a 2 or a 5, bam, you know it's going to be an infinite decimal. It's really that easy. So here it is, the secret rule, all laid out. First, you simplify the fraction. Second, you break down that bottom number into its prime factors. And then, the moment of truth. If you only see 2s and 5s, you're looking at a finite decimal. It stops. But if you see any other prime factor in there, like a 3 or a 7 or an 11, you know it's going to be an infinite decimal. It'll go on forever. And that's it. That's the secret weapon.
Okay, so we figured out that some decimals go on forever. But here's something really cool. When an infinite decimal comes from a fraction, it's not just a random jumble of numbers. Nope, there's always a pattern. Let's take a closer look. We call these guys repeating decimals, and it's exactly what it sounds like. A digit, or maybe a whole group of digits, just repeats over and over and over again, forever. And that part that repeats, we call that the cycle. So see, they might go on forever, but they're not chaotic. They're actually super predictable. Now, writing ... all the time is kind of annoying, right? So there's a really cool shortcut. If you have 0.5555, you just write 0.5 and put a little dot right over the 5. That dot means this repeats forever. What if the pattern is 12, like in 0.121212? Simple. You put a dot over the 1 and a dot over the 2. For a longer one, like where 215 repeats, you just put a dot over the start of the pattern, the 2, and the end of the pattern, the 5. It's just a clean, simple way to write it. Okay, we've gone from fraction to decimal. But can we go the other way? Can we actually take one of those crazy, infinite repeating decimals and turn it back into a fraction? The answer is yes. And honestly, the way we do it is like a little math magic trick. You're going to love this.
Let's try to capture 0.7777. First step, let's just give it a name so we can work with it. Let's call it x. So x equals 0.777 and so on. Now, here's the trick. We need to get rid of that infinitely repeating part. How? We're going to make a copy of our number, but shift the decimal point. Since only one digit is repeating, the 7 will multiply by 10. That just slides the decimal one spot to the right. So now we have 10x, which equals 7.777. See what we did? Now, here comes the magic part.
Okay, so we're going to subtract. We'll take our bigger number, 10x, and subtract our original number, x. Look at how perfectly this lines up. On the left, 10x minus x is just 9x, easy. But on the right side, watch this, 7 minus 0 is 7. Now for the decimal part, 7 minus 7 is 0, 7 minus 7 is 0, 7 minus 7 is 0, all the way to infinity. That whole messy, infinite trail of 7s just disappears. Poof, gone. And all we're left with is this super simple little equation, 9x equals 7.
And from here, it's a piece of cake. If 9 times x equals 7, what's x? We just divide by 9, so x has to be 7/9. And that's it, we did it. That crazy, wild, never-ending decimal, 0.777, was really just the simple fraction 7/9 hiding in a costume. We caught it.
And this leads us to the biggest takeaway of the day. Every single repeating decimal, I don't care how long or complicated it looks, can be turned back into a fraction. This is why we call them rational numbers, because they can be written as a ratio, a fraction. So they might look crazy, but they're not really mysterious at all.
So, this leaves us with one last really big question to think about. We've seen that all fractions turn into decimals that either stop or repeat in a nice pattern. So, does that mean there are other kinds of infinite decimals? Ones that go on forever, but with no pattern at all? That's a great question, and it's a mystery for another day. Thanks so much for joining me today. You were all amazing math detectives. I'll see you next time.